The aim of this video is to teach you how to draw a Born Haber cycle. A Born Haber cycle is a more elaborate Hess's cycle. You should have learned about Hess's law in AS Module 2. It states that the enthalpy or energy change for a reaction is independent of the route taken, providing the conditions at the start and the end are the same. A Born Haber cycle takes us through a lot of important changes involved in the formation or the breaking up of an ionic lattice. For example, sodium chloride. My first step when drawing a Born Haber cycle would be somewhere towards the bottom of your page or workspace to write the formula of that ionic compound in the state that it is commonly found, in this case a salt. The Born Haber cycle is a way of working out what is known as the lattice enthalpy. Now, the lattice enthalpy is defined by our CCEA clarification of terms as the enthalpy change when 1 mole of an ionic compound is broken apart into its gaseous ions. This number is always positive. The sign delta H LE, or lattice enthalpy, into the gaseous ions that it is made up of. The whole point of a Born Haber cycle is to find the unknown lattice enthalpy by using Hess's law and going through a number of changes that we do know. This is what I'm going to talk you through now. A change that we became familiar with last year was the enthalpy of formation. The enthalpy of formation is the enthalpy change when 1 mole of an ionic compound is formed from its elements in their standard state. In this case, for sodium chloride, the enthalpy of formation is from sodium as a solid, and note, half a mole of Cl2 gas, both in their standard states. The enthalpy of formation in most cases is a negative change. It's an exothermic reaction. So the arrow goes down. Other changes that we should have learned about in A2 involve the change from solid atoms to gaseous atoms, known as atomization. Ionization, removing 1 mole of electrons from gaseous atoms to form single positively charged ions. And we are going to think about each of these changes in turn to enable us to find the change from here the whole way around to our gaseous ions. I would advise you to take each element in turn. What changes do I need to do to my sodium to get it from Na solid to Na plus gaseous? Firstly, it must be atomized. Note, my Cl2 remains unchanged. Secondly, my sodium must be ionized. This is the first ionization energy. Note, my half Cl2 still remains unchanged. My sodium ions here and here are now the same. I then need to take into account what I have to do to my chlorine. The change from here to here is carried out in 2 steps. Firstly, my chlorine must be atomized, turned into gaseous atoms. It exists at the moment as gaseous molecules. So, my line, again, endothermic atomization of chlorine. I have produced chlorine atoms. The final change that I have is from here to here. This is where my chlorine gaseous atoms are turned into gaseous anions. They have gained an electron. This is known as the first electron affinity, or EA, of chlorine. It's an exothermic change. Here you have a complete Born Haber cycle for sodium chloride. If you know each one of these changes, you can calculate the unknown lattice enthalpy of sodium chloride.